again, students, thank you so much for joining me with another math lesson with Mr. Whitford. Today, we continue to work on Unit 4 as we look at our very next lesson, lesson 4.7. We're going to continue to talk about angle measurements. We're going to talk about measuring angles, however, in this case. And I want to talk about obtuse, right, and acute, right? These are words that you may have heard before. They may have been taught to you in the past, but I do want to refresh you on it. So if you have your packet with you, please open up to 4.7, where we're going to look at measuring angles. Now, if you notice at the top, there's the title, and next to the title, there is the code that I told you guys that aligns to the actual standards. But next to that, there's this picture of a protractor. That is a protractor, okay? We are going to use this protractor to be able to do it. So if you have one at home, great. If you don't, I know when we're in class, I have a full class set, so we'll use those. But I'm looking forward to us playing around with this, really understanding how to use the protractor. All right, a protractor is a means to determine and calculate the angle measurement of different shapes and stuff like that. So we're going to use that on paper for these two-dimensional shapes to be able to find the different angle measurements. But before we get into that, as usual, take a moment to pause the video and answer the bell word. A is asking you to identify this particular angle by drawing an arc, as we did in the previous lesson, and B is asking you to give me the name of that angle, as we also did in the previous lesson. All right, since there's a lot of content to cover in this particular video, I do want to quickly just draw the arc, give you the name, and if you do have a question about it, I would love to talk to you about it, and you can put the questions in Google Classroom, where I will answer them for you. The arc that you should have drew looks something like this. That is angle ABC. And the name of this angle here, you could have named it two things. You could have named it angle FED, or you could have named it angle DEF, right? As long as E is in the middle, it is okay. All right. You can't use any other letters, obviously, on the outside. It has to be D or F, but it's either one of these two configurations, okay? Let's look at the vocabulary for today. All right. We've talked about there are types of different angles, right? In your past, you may have learned about a right angle, right? And we talked about right angles, especially when we talked about triangles the other day, right? This is what a right angle looks like. It has this box that's in the middle. That box is indicating that that was right. It's squared. So that means that there's a 90-degree angle. You may have learned about an acute angle. An acute angle is less than 90 degrees. It's an angle that normally looks smaller than a right angle, right? It indicates that it's less than 90. An obtuse angle, you've probably also heard about, is bigger than a 90-degree angle, but it's less than 180, and that is called an obtuse angle. There are two other angles here, specifically a straight angle or a straight line, they call it. This is 180 degrees, right? So if you see one 180 degrees, that means it's a straight angle. There are other names and other different types of straight angles that we're going to talk about, and combinations of angles, such as supplemental angles that equal 180 or linear pairs. But for now, I want you just to see these visuals of what you're looking at. These are the type of angles that we're going to use today to be able to determine, is it acute, is it right, is it obtuse, or is it a straight angle? Okay, and obviously around the one given point is 360 degrees. I want to talk to you about how to use something called this protractor. How do I use a protractor, Ms. Wilfred? I wrote out steps for you here, as well as a diagram indicating what the steps are. So if you ever get lost, come right back to the first page on this worksheet and look and read through each step. I'm going to read through them, try to help you understand exactly what they mean. And I want you to think back and just use this as help if you need it, okay? If you look at the right quickly, there's a diagram. And in this diagram, there are 4 steps there, the same 4 steps that are on the left, but you'll see that there's a purple angle, or an angle that says 103 degrees, okay? How do I know this is 103 degrees? I need to be able to figure out what it is. Now, you're gonna be given angles today that are not gonna tell you what the degree measurements are. You are gonna have to calculate them. You're gonna have to find them using this protractor, okay? The way you're gonna do it is you're gonna first put the center of the protractor on the point of the angle. Now, what point exactly on the angle? Let's call that the vertex. Let's change the turning point, okay? Let's put it on the vertex. Okay, and I'm gonna call the vertex the turning point, okay? So you're gonna put the center of your protractor on the turning point of the angle. Whatever angle you're focusing on, put it on the turning point of that angle. If you look at the diagram, you'll see that this line on the protractor represents the center of it. And you'll see that the turning point of the angle is right there on the center. Okay. Now, on some protractors, you need to understand that the actual numbers that we're going to use to calculate the angle measurement does not start directly at the end of the protractor. So there might be a gap that's needed for you to fill. Do not put it at the end all the way down here. Notice this protractor is not like that. It actually is moved up a little bit, so that way it's aligned with 0, aligned with the numbers, okay? But the center is right, the center of the protractor is on the turning point of the angle. Okay. The second step is to line the 0 line of the protractor over one side of the angle. So this side of that angle, which is that straight side, you'll notice that it's directly parallel, or it's aligned with the number 0 on the protractor. It's not down here. It's not the end of the protractor, because that's not where the protractor starts calculating the actual degree. It starts a little bit above it. So you make sure that line is straight. And there is this T that's created on the actual protractor to help you make sure it is straight on that line on the bottom part of the angle, okay? After you did that, then you make sure you start counting up until where the angle is. Now, I want you to understand, on some protractors, they have a 0 to 180 going both ways. They go both ways. So sometimes you'll see 0 on 180 on this side and also 0 to 180 on the other side, right? Wherever that base of the angle is, make sure you start counting at 0 where it is. Even if you see 180 there, look at the number 0, okay, and then start counting up. In this case, I start counting up. I see that this angle is bigger than a right angle. It's bigger than 90. I keep going. I notice that it is at 103, and that's how I calculate that. I go as far as I can and say, where is this angle at exactly? In this case, it's at 103, okay? That's how you're gonna use your protractor. Don't worry, of course, as with every lesson, I am gonna model it for you so you can see exactly what I'm asking you to do, but these are your steps in case you get lost, or you can always rewatch the video as well, okay? Let's look at the modeling. I'm going to do 2 problems for you, A and also B. I want to know, what is the angle measurement of this angle, right? And I also want you to classify for me, right? Maybe you're able to classify the angle right away with no problem. You see that this angle is smaller than 90. You see how it looks. It looks like a small angle. Maybe you could tell me right away that this angle is an acute angle. Okay. Maybe you can tell me it's an acute angle. All right, same thing with the second one. You see that it's also a smaller angle. Maybe you want to tell me that this one is also acute, okay? You know if it's bigger than this, if it's bigger than 90, you can tell me it's acute. If it is 90, you can tell me it's a right angle. Now, why did I put 2 acute angles for me to model? Because they look different. They do look different in terms of the direction that they're facing. And I want to show you how to calculate the angle measurement when they are facing this way. Okay, so first thing you're gonna do is take your protractor, and I have my protractor on the screen. I'm gonna grab it, and I'm gonna just move it over to where my angle is. I might make it a little bit bigger so you can see it and we can read it together, right? But if you notice, right, I have a center point here, a little circle in the middle that's open. I see a horizontal and a vertical line that moves. I'm gonna put that center right on the vertex or the changing point of my angle. Now I'm going to use my coloring just to highlight so you guys can all see. Okay, that's the center of this angle. I see that the side comes out this way and the other top goes out this way. If you need to trace over it, or in your case, students, just draw an extension of that angle so you can see it and be able to count exactly where it's at, that's okay. You can do that as well. Notice that on my protractor, like I said, there's numbers that start at 0, and then there's numbers that start at 180. Whenever you start to count, you need to make sure you're starting at 0. And Ms. Whitford, I also see 180 there. Do not. Because if you start reading from 180 and you go up, you're going to think that this angle is about 125, where you and I both know that this angle is less than 90. So how can it be 125? You have to make sure you start reading at 0 when you go to read the angle. But just to recap once again, I take my protractor, I put it over the angle, I make sure the center of the protractor is aligned to the vertex, the turning point of the angle. And then I make sure also that the base of the angle, that straight line, is able to go right over to where 0 is. Then I start counting from 0, 0, 10, 20, 30, 40, 50, and I see it's between 50 and 60. Okay, if I could zoom in if I want to on your papers, you could get a better look at it if you wanted to. I'm going to say that this angle is about 56 degrees. Okay, but that's by me looking and observing where it's at. Okay, so I'm going to write that here as my angle measurement, 56 degrees. Notice I'm going to make sure I put a little circle here. That little circle is a degree measurement. All right. If you want to write the word degrees, feel free to write the word degrees. But this is my way of indicating that this particular angle, when I use the protractor, it measures 56 degrees at all. Okay. Let's look at B. Okay. Once again, I'm going to use the protractor as well. We already discussed that it is an acute angle, which means that it has to be less than 90. But the reason why I put it here, you can see it looks different than A, right? Why did I put it here? Why would you put another acute angle, Mr. Why can't you model an obtuse angle for us? The reason is because I want to show you how to measure angle no matter where the bottom of the angle is facing, whether it's facing to the right or facing to the left. In this case, this one is facing to the left, whereas the one before was facing to the right. Notice I take my protractor, I put it on the angle. I put the center of the protractor on the vertex, the changing point of the angle, and I make sure and I'm going to trace it because I want to show you what I'm looking at. I make sure the base is heading towards the 0. For Mr. Woodford, it looks like it's heading towards 180. There is a 180. There's also a 0 here. I told you on some protractors, they show, most protractors show on both sides 0 to 180, 180 to 0. That's kind of how protractors are. But when I go to count, I'm not going to start counting at 180 because then I'm going to think this angle is between 150 and 140. And that's not true. I know that this is a small angle. So since I know small angle, I need to start at 0. I'm going to count 0, 10, 20, 30, and I see it's between 30 and 40. I'm going to say it's a little bit bigger than 30, a little bit bigger than 35. And it looks like it's a little bit bigger than 36. So let's say it's 37 degrees. Okay. I'm going to write this angle out as 37 degrees. Now, I want to mention one more thing before we end the video today. It's okay to be 1 degree, 2 degree, 5 degrees, plus or minus in either direction. It's okay. I'm looking for the closest assumption of that angle. Now, I would like to get the most exact angle possible. But for example, if you said that this degree was 38, I'm not upset at you. If you said it was 35, I'm not upset at you. If you said the first one was 53, I'm not upset at you. But if you said it was 68, if you said this one was 52, then you are wrong. Okay. I want to be at least 5 degrees positive or negative in any direction of these actual degree measurements. Okay. All right. So that is what you're doing for today. If you need to pause the video, if you need to rewind the video, I recommend it. I know that using this tool, which you're probably never using in your life, is new. It's different. That's okay. Take a moment to rewatch the video, pause the video, type in any questions or all questions that you have in Google Classroom. I look forward to learning with you and look forward to hearing all your comments, okay? Thank you so much for joining me with another math lesson with Mr. Woodford. Have a wonderful day.